Full screen up and running. All right, so lesson 8, it's going to be a mental math exercise in class where I'm going to ask students to just write their answers without showing any work, without doing any work on the board. Just how many problems can you do? How many things can you look at and just write an answer for? I have to do that when I have multiple classes and I'm asking 60 to 100 questions per test. And I've got create the test, write the answer key. I don't have time to write out much. So I usually make 2 or 3 mistakes in a test of that length and mental math errors. But I think it's really good for the brain. It's like, if you're running a soccer practice, confining space on a possessional drill is good for players. I mean, it makes you work harder. So mental math makes you work harder. So here are the problems. You can screenshot this maybe, and I don't know what's the best way for folks to follow this without the worksheet in your hand, but you can freeze that and I've got all of these problems around the room with a little more space, and I'm just going to do them in my head and then show how to do it for folks who are just learning how. All right, but you try each problem that I show. I guess I got some more problems here that I just hold the camera here steady for a second and screenshot, or I'm going to do some graphical and algebraic solutions here with some just four functions. And we're going to just get a little feel for whether our answers are right graphically and then do them out. And so let's have at it. And I will look at a problem and say, can I write the answer down on an answer key? My answer keys are, problem number 1, there's a line, problem number 2, a line, just putting the answers there, and then I can correct quickly. And I'm a big fan of volume. Let me get an eraser and we'll have at it. All right, so, and I'll try to keep this camera centered where it belongs. And I'll get on this side of things and let's go for it. So square root of 90 is 3 root 10. Okay, I think this may run out of ink. Well, let's see if we can get through this without it. All right, so how did I know that? Because I can see the square root of 9 times the square root of 10, 3 root 10. I'm not going to be able to get through this without getting another marker. So let's just hope that one of these is dark ink. Looks like I got a couple of good ones here. All right, next problem. Remember, you're going to try to do the next problem in your head, and so am I. So I'm seeing positive 9i squared, so 64 minus 9 is 55. And I'm going to double that, so minus 48i. I believe that is the correct answer. So if I square that, I get 64. If I double that product, I get minus 48i. And if I square that, I get positive 9i squared, which means I've got minus 9 from 64. I'm looking good here. All right, so now we're looking at the next problem. So name that tune. I see absolute value centered at 5, 7. I know it's a negative because it's V-shaped down. So 7 to 9, 16 units of change, 5 to 0, 5. Not much else I can say about that one. Okay, we're going to be drawing triangles in standard form, getting to trigonometry shortly. Soon we're going to be doing 3 functions, sine, cosine, and tangent. And it hinges on good drawings, get good answers. There's the origin. I want to go over 4. Oh, I'm just getting an answer here. 16 and 25 square root of 41. So I should get the square root of 41. So if I go over 4 and down 5, I've got that Pythagorean relationship, and the hypotenuse will always be positive. So 16 and 25, I hope you can see the 16, the 25, add those up and take the square root. So I'm hoping students can just write that answer. So a 3-second question, roughly. All right, so how do I do this on my answer keys? Because I'm not going to write things out. I know I'm squaring x and multiplying by -4, so I simply write minus 4x squared. I know minus 2 is going to get doubled, so minus 4 times minus 4 is 16x. And I know if I put a 0 in, I get the constant, so I got 4 minus 16 plus 6, I believe, is minus 10. You go ahead and do it out. minus 4 times, you have to square that, which is x squared minus 4x plus 4. And then add the 6 here, and hopefully you're going to get what I got a minute ago. Okay. So I look at this and I go, what did I ask? Oh, perpendicular to this. And if you've been looking at, and I've been suggesting you look at your answers, then you'll know the perpendicular is given to you. 27 over 14, x plus 2 plus 9. There's my function that's perpendicular to this line. Now, some students are still struggling to get the correct slope and know the negative reciprocal to get there. But I think showing you that if you pay attention and you know how to do a problem and you can see the answer without having to do any work, it's useful. It's a useful thing. All right, so that's that. Okay, we're coming over here and we're doing a factor, which means write this as a product. So when I look at this, I know 84, 4 goes into 84. So I know that it doesn't evenly go into 86. So I'm going to take a 2 out. And then I'm going to build back these numbers. So there's a 2, and then there's a 43. I take out the smaller one, which is x cubed. So I don't need anything here, but I need 6 there. And then I want y to the 12. Well, certainly not common here. So it's got to be here. I must have missed, I probably missed writing something on this worksheet. But that's what I would do on my answer key so that I could just, get through a day without having to spend 6 hours writing out everything. I forgot what I answered, what I asked here, probably 3 coordinates because I didn't show the division by 1. So is that what I would have shown? Probably 3 coordinates. Okay, so what are they? I'll start with an x value of 7, and I know I'm changing by 1. All right, so I would put those numbers in. I know over here I need a 5, and I'm going down by 2. All right, I would put that on an answer key. And I might check 9-1 just to verify, because it's easy to make mistakes. 2, -4, I see it. So, okay, so that's correct. Maybe you're pausing the video each time. So I look at a problem like that and I go, okay, 2x minus 2 equals 3x. So 2x, so x equals -2. That's what I'm getting. I hope I'm right. So let's do this one out. 4 could have been 2 squared. 8 could have been 2 to the 3. But say it takes me time to write this stuff. So therefore, I see 3x on this side. I see 2x minus 2 on this side. And I see that x could equal -2. I like my answer. All right. -2/3. Now this one, let's see. That's going to be a little nasty, so I probably would have to put pencil to paper. But for the practice, push the brain a little bit, I'll try it. So -8 27ths. So I got to have 27ths. It's got 32 27ths, I think, 32 27ths. And 7 times 27 is 140 and 40 and 189. No, I can't do it in my head. All right, so I've got to do -2/3, which is -8 27ths when I cube that number. I'm multiplying by 4. So I was correct with 32, but I think I said positive 32 in my head. So I would have made a mistake there. And now I've got to get 27ths. 7 is how many 27ths? And I'm adding 27ths. So I've got to do 7 times 20 plus 7 is 140 and 49. So 189, I had that right. But I think I would have made a sign error here. So if I take 30 away and 2 more, I believe I'm at 167. 167 over 27. And that's where I'm probably going to make a mistake. Somebody will correct it for me. And then I'll amend the answer keys. All right. G of x equals 5. Well, you've done it enough times now that I hope you know you're setting this equal to 5. All right, so you can do that in your head. -2 minus a half. The cube root of -1/2 is the opposite of the cube root of 1/2. We've got an odd function there because I know the cube root of 1/2. No, I don't. I know the square root of a half. I don't know the decimal approximation for the cube root of half. All right, so, and I would have accepted the minus sign there, but you don't want a plus minus in front of a cube root because the inverse of cubing, that's cubing, the inverse of cubing looks like that. That's cube root. All right, and it's 1 to 1. So If I want to talk about minus 1/2 is here. There's only one answer. It's not two. So odd roots, don't put a plus minus in front of an odd root. And that's g of x equals 5. Okay, graphing form. Well, I know that that is going to happen. I've seen enough problems to know that's going to happen. So I just got to take 20 divided by 10. It's 2. Yeah, so it's just a 1. Okay, and if I put a 1 in, I've got to subtract 10 plus 9 minus 9. All right, so minus b over 2a should equal 1, or I've made a mistake. Minus b, 20 divided by 2 times 10. So the 1 looks good. And if I put a 1 in here, let's see if it comes out. 10 minus 20 plus 1 gets me 11. Well, minus 20 plus 11 minus 9. All right, so we're moving along. What do I have next? Center the darn camera here. I guess you can see. So what did I ask for this one? I don't know what I asked. Oh, probably minimum. That's kind of where we're at in the term. So what's the minimum value? Well, I know it's cup shape up. I know that I'm on the downside. I'm on the downside for 0. So therefore, that's a positive number. 5 goes into 24. Cut in half is 2. My minimum is going to be what I get when I put a 2 in. And so that's going to be minus 10 plus 11. No, minus 40 cut in half. Minus 20 plus 11. Minus 20 plus. Oh, I just did the problem over there. Was it the same one? No, it was different. Coincidental. Okay, so I should get minus 9. Let's check that. If I did that in my head properly, those are the steps I would have taken. So minus b over 2a, that's really all you had to do. So 20 divided by 10 is 2. And if I drop a 2 in, if I drop it in here, I've got 20 minus 40 plus 11. That's why I cut that in half. And minus 20 plus 11 is minus 9. And that's the minimum value. I can see the next one. You keep pausing the video if you want. How do I get from minus 3 to positive 17? I got to go up 20. So I hope you can see the foiling that gets us the first two terms. So minus 3 times 20 is minus 60. How do I get from minus 60 to minus 4? I got to add 56. So I would just write that answer down. I probably would check this. At this stage, my brain's probably getting tired from writing tests and answer keys. So I'm going to use the critical number over here. 3 gets me 56. Okay. And I could have put the 56 on the outside as a remainder. And I hope you can see why 3 gets you 56 now. So over here, a 3 has to get us a 56. So we'll plug it in and we get 9 plus 51 minus 4. 60 minus 4 is 56. I move on. Didn't make a careless error. Okay, so we're getting to exponentials. It's a little early, perhaps, to do this problem at this stage because students are still learning how to write that equation, but got to get it in front of us, and so we're going to do it. So you start. Y equals 0. How do you get from 0 to 1? You add 1. The next time you don't add 1, you go from 0 to 2.71, 2.71. Those are your differentials. Talking about those a lot. X minus 0, all divided by 1. Okay, we'll take more time with that in class. And now I will ask students to get rid of all unnecessary symbols. And if you do get rid of all necessary symbols, you don't have to write 0. You don't have to multiply by 1. You don't have to divide by 1. You don't have to divide by 1. You don't have to subtract 0. You basically get 2.71 raised to the x power. And why am I doing this? To show that e to the x, this is an approximation for e to the x, one of the most important functions going to work this term, is an exponential function, somewhere between doubling and tripling. Okay, that's all I'm going to say about it right now, because we're going to start graphing that, working with it, getting our rules of logarithms from it. A lot of stuff's going to happen now that we put that in front of us. Okay, looks like I'm in a corner here. Yeah, I've been in a corner all my life. Yep, I got cornered early on. All right, can I do this one in my head just for practice? Well, I would look at this column and I would multiply by -5 to get rid of the y, so I don't have to think about that. Negative times negative, 15 and 4, 19. So I should have an x value that I'm dividing by 19. 20 plus 18, 38, 19. Oh, that's a 2. Oh, that's nice. I like that. Now I can plug it in. So if x is 2, I got 8 plus 5y. Well, I'd be doing this in my head, right? So y is 2. No kidding. Let's check 2 and 2 here. -6 plus 2. Oh, I got lucky. I got real lucky because that just reduced so nicely. So what did I do? Well, I looked at this problem and I said, wouldn't it be nice if that number right there was -5y? Because then I could add up the columns. And wouldn't I get -5 times -3 is positive 15x minus 5y plus equals 20. And wouldn't underneath it I have 4x plus 5y equals 18. And when I add them up, they're gone. That's why it's called the elimination method. And there's my 19x. There's my 38. I got lucky. I didn't get lucky. I must have made that up. I made these worksheets up years ago. All right, but they're appropriate for where we're at right now. So I see an x minus 2. This is name that tune, I'm sure. Plus 7. So I've got a cup shape down, so it's got to be negative. And so I've got 7 to 1 is 6 units of change, and 2 to 5 is 3 linear. But if I go over 3 units and square it, I should have gone up 9, but I really went down 6. So I got rid of that differential and brought that one in. I'm starting to use the word differential, and I'm going to make another video soon about something that has come to mind, all prompted by Yasser. Yasser was going to look at implicit differentiation, and that got my brain going. And I'm going to share where I went with it. So thank you, Yasser. All right, so that's a 9. And of course, you can reduce that to 2/3. All right, back to the desk over here. I'm still in the corner. All right, let's turn that around. Rene Descartes downstairs on the 2nd floor, and I'm on the 3rd today. So I want to get the inverse of x to the 3 plus 9. I'm not going to do anything here. I'm just going to subtract 9, and I'm going to make sure that that new number gets multiplied by 3. Real important Algebra 1 skill. I've created a new number when I subtract 9 from x. So how do I check this? Some easy number. Let's put a 12 in. 12 divided by 3 is 4. 4 plus 9 is 13. The inverse means that 13 should kick out at 12. Let's find out if it does. 13 minus 9 is 4 times 3 is 12. I'm moving on. All right, so think 3 coordinates here. Did I already do 3 coordinates? I think I did. So let's do slope intercept for this one. And I'm not sure which one on the sheet we'll do tomorrow that way. So I might be mixing that up, but let's write this in slope intercept. I see minus 2/5 x. I see minus 18 plus 5. I see minus 13/5. Let's check that to see if it's correct. I'll check it above. So let's see if that comes out. So first off, I'm going to do minus 2/5 x minus 18/5 plus 1 when I bring the 1 over. 1 can be written as 5 over 5. And so, yes, that was minus 13/5. So all good and done. All right, so I look at a problem like this, and I go, well, I know it's a trinomial that can be factored on the left side, and I know that I'm 2. So I'm looking at numbers like 3 and 5. So I'll put 5 in, and I'll go, well, that doesn't work. Then minus 5 and positive 3 probably. I don't want to write it as a coordinate. So x equals minus 5, positive 3 probably works. So I'll throw a 3 in. I got 9 and 6. Oh, yeah, that's 15. And I move on. Now, what did I do? In my mind's eye, I did x squared plus 2x minus 15 equals 0. And yes, 3 and 5 were the keys to answering that. And I want a positive to win. So plus 5 minus 3. Now you can see negative 5 and 3. All right, so it looks like the sun went behind some clouds. Is it too dark in here to you? Oh, Lord, I hope you can see all the problems I've done. Where are the lights? Goodness, oh, they're right over here, right next to me. Yeah, let me put some light on this. There. I'm not gonna make the video again, so what do I have to do to 1/3 to make it a 9? I gotta flip it and square it. Okay, so what do I have here? I have, we talk about those in class. We've certainly done enough practice that most of the students should have that, and so they can help each other figure that one out. So y equals, well, I see 1900. I know to get to 205, I gotta add 105. I got a logarithm. Asymptote at 3, so x minus 3. My change in x is 4. So that's actually a differential of 4. The next differential, 3 to 11, is 8. So I have a base 2 log. But to see base 2, you can take the next x and plug it in. Whatever's in the parentheses is your base. 11 minus 3 is 8/4. And there's your base 2 log. And all these problems are somewhere buried in the YouTube channel. I didn't realize that I'd be doing this 5 years ago, or how many years ago it was with COVID. But I am retiring, and I'm just deciding to put some courses out there. Might even do one of these lesson sets with trig, more of a pre-cal, and also more of a calc AB. That's what I used to teach. So I have hundreds of worksheets, progressive worksheets, building simple concepts into more difficult concepts, and that's the approach I take. All right, so that's there. And I can't really use a textbook because that's not in the textbook. So this templated practice of writing equations isn't in the textbook. So that's why I started writing my own stuff. All right, so that's there. So let's see, moving along. New problem. So what's the answer to this problem? Well, it's 21/4. How do I know that? Because I know it's asking the question, m to the 4 to the what equals m to the 21. And I want m to the 21, not m to the 4. So I got to get rid of the 4th power with a 4th root. That cancels that. And I bring in the exponent I want. Okay, I think somebody stole that process from me many years ago. Get the change you want, kind of like a political slogan, something like that. Get the change you need. Just get the changes that you have to have. Okay. 16 to the minus 3/4 is 2 to the negative 3, which is 1/8. Right? You can either take the 4th root of 16, or you can do 16 to the negative 1, or you can do 16 to the 3. Which of those did I do first? Obviously, I did that one first. I don't like the word obviously. I take that back. Nothing's obvious to anybody until you learn how to do it. Okay, so the 4th root of 16 is 2. And then I took that 2 and cubed it, made it 8. And then I took that 8 and flipped it to make it 1/8. All right, so binomial squaring. I'm hoping everybody can do that in my class now by just writing the answer, 9x squared minus 12x plus 4. You're not sure, then do the foiling and see why that comes out. And then hopefully you can look at this and say, how could I get there? Well, if you multiply that, you get minus 6x, just as a hint. Oh, big gap here between problems. All right, wish I had Renee with me. Y-intercept, so I'm going to plug 0 in here. I'm going to do that in my head. So that's 1/3, that's 2/3, that should be 5 2/3. Let's see if that is. So first off, put a 0 in. 3 to the negative 1 is 1/3. And I hope we can see 2/3 plus 5, 5 2/3. What did I ask here? Yeah. Probably another slope-intercept form. Nah, I don't want 4. Let's do an inverse. All right, let's call this g of x. I'm not sure what I put on there. Let's do an inverse. That could be more fun. All right, so the first thing I see is I need to start with a number, and that number is the output of this function. Okay, and if I was solving an equation for that output, I'd add 8, I'd multiply by 4, I'd divide by negative 3, and the last thing I would do is add 5. All right, so that's the inverse, and that probably is, these probably graphed would form the midpoint of y equals x, planting a seed. Okay, hope I didn't make a mistake. And if I do, I know I got a backup over in lower. That is very helpful. All right, so we're just solving the equation, so we're going to do that in our head. So I'm looking at -2, 193, and 19. Okay, so I'm hoping my students get that. Mental math. So what did we do? We divided by -3. So that's -2. We undid log base 3 with 3 to the, and that's 1/9. And then we added 3 to 1/9. And I hope that's what I said before. Not sure, because my memory doesn't exist past 20 seconds. And I think that was past 20 seconds. All right, so now we're moving along. I had Renee with me. Writing the equation of a line, which used to be not known how to be done on day one, despite an Algebra 1 class already having occurred. So I think I'm very happy with my students who simply write x plus 14 plus 30, change in x 15 units, change in y down 18, and then of course you could reduce that fraction. Okay, factoring. Well, I know I got to have a 2x. I know I got to get an eraser going. All right, so 2x times x gets me the first term. And then I'm contemplating what factor of 4 gets me close to 7. And I would say 4 does. Because 4 times 2x is 8x. 8x and 1x are 7 apart. And I want that to be negative, so that's a negative and that's a positive. That's how I would approach that. This one here, I would simply write as x equals 5 plus or minus the square root of 6 over 2, just by looking at it. Because I've got the vertex and I got the a value, and I know I can do it. Now, I would change that to 3. Okay, so what do we have? Subtraction of 6, addition of 6, multiplication, division, undoing square rooting, plus minus, and then bringing the 5 over. Did I capture that? Yes, I did. Okay. Oh, we can see these, but I'll move the chair over a little bit. Move the chair out of the way. Captain's chair. All right, I see a square root problem. So I know I've got the square root of x minus 8 plus 3. I know I have a negative square root. Things are going down from 3 to 6. That's 9 units of change. And 8 to 15 is 7, but I'm getting rid of square root units, so square root of 7 gets the job done. That would be on the answer key, and I don't even care if you write equals y. We're after thought process here. Okay, f of x equals 2x squared, g of x equals 9. I think I asked where they intersect. All right, so where do they intersect? Well, they intersect when 2x squared equals 9. So that's going to equal plus or minus 4 halves, 4.5. We'll do 9 halves. I don't care if you change that. That's the x value of intersection. And since 9 is constant, then they intersect at this comma 9. So that's where you have intersection for 2x squared equals 9. Yeah. Boom, boom, because it's centered at 0, 0. Now, if I square that distance, I go up 9 over 2, but I got to go up 9 units. That's why there's doubling there. All right, now, my students have not seen any sinusoids, and that doesn't bother me at all, because I'm just going to write the equation and see if people can pick up a little bit about where numbers come from in writing this equation before we even start talking about radian measurements and triangles and the ratios. Not even going to look at that yet, but I can see that this thing starts at 40. I'm going to go up 10. I'm going to make it a sine function, and I'm going to make 1900 kick out to be pi over 2. That's linear concept, and I'm going to make 2005 be a change of 105 units. And I am going to go to 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. Made that happen. It can't be rocket science if I wrote it that quickly. So later in the term, and I would assume that's going to be within about 2 or 3 weeks, some of the students in class will be doing that. And that'll be nice. Okay, getting there. X and Y intercepts. Oh, there's no work here necessary. You put a 0 in, you got negative 50 over 49. 0 gets you negative 50 over 49. That's your Y intercept. If you put 0 in for Y, we're going to get our X intercept. 0 into 50 over 17. No work needed if you put some effort in. Listen to the commentary in class about how you find X and Y intercepts for a line. Okay. X squared plus 4x, points of intersection. So, okay, so what do I see? I'm going to do this graphically yet? No, that's over there. So we're going to set them equal to each other. X squared plus 4x equals 2x plus 8. All right, so would I try anything here? I don't think so. I think I've got to do x squared minus 2x minus 8 equals 0. Now I can see my answers. I think I probably put pencil to paper here. Getting close to the end of answer key, brain gets tired, and you start to not do things correctly. So x minus 4 times x plus 2 equals 0, and I can see x equals 4 and x equals negative 2 are the x values. If I want the y values, I got to plug them in. So let's put a 4 in here. 8 and 8 gets me 16. Let's put a 4 in over here, and I don't see 16. So did I make a mistake? Yes, see, that's why I did that. And now I told you my brain starts to get tired. When I bring the 8 over, that's correct, but the 2x should have been positive. So I have a sign error. I've corrected it. I'll put a 2 in to make sure I'm right. 4 and 8 is 12 when I put a 2 in. 4 and 8 is 12. Now I move on. Okay, that's a quick way to find out if you make a sign error. That's why I did it. Talking to you rather than thinking. Okay. So that's that. First line of work. That's all I'm interested in here. If you can get the first line of work here, then I'm sure you're strong enough to get correct answers. So what am I going to multiply by? I'm going to multiply by 10. So therefore I got minus 4x minus 10 equals 15x minus 20. Now let's put the 10 out here and you take more time with it. And see if you get that. I will see if I get that too, because I'm towards the end of the worksheet. Double checking. I like it. I'm going to move on. I'm assuming you can do the answer in your head here. Try to do the answer in your head. You're going to get a division by 19 and you're going to get a 10. All right. 5 root 15 becomes 5 root 3. Root 5 times root 15. Why? Because root 15 is square root of 5, square root of 3. And I know another name for the square root of 5 times the square root of 5. It's 5. Okay. X squared plus 6x equals 8. Now we're starting to do graphical solutions, approximations. So I'm going to do this. I'm going to do these out. I look at x squared plus 6x, and I'm seeing x times x plus 6. That's what my brain is seeing. And that means I have a cup shape up, and I know negative 6 and 0 get me 0. 0 also gets me 0. I want a height of 8. A height of 8 is above 0. So I want an answer that is greater than 0, but I also want one that is less than negative 6. And if I don't have those, and I know that magnitude-wise, the one on the left has a bigger magnitude than the one on the right. So now I come here and I do the algebra. And I think we just did one like this. So this is x minus, that's not factorable. Okay, so we're going to leave it. Yeah, brain is tired. So we're going to leave it and we're going to complete the square, which is going to be x equals negative 3, right? Plus or minus the square root of 17. There's my mental math. Let's see if I'm right. So x plus 3 squared minus 9 equals 8. Yep, I'm feeling pretty good. I'm going to bring the 9 to the other side. So I'm going to get plus minus the square root of 17. And I got the positive 3, so I got negative 3. And those are my answers. And square root of 17 is pretty close to 4. So minus 3 plus or minus approximately 4. One of my answers is just a little bit bigger than 0. And the other one is a little bit less than, certainly -6. So I like those answers. Hope I didn't make a mistake because getting tired. All right, so graphing first. I see V shape. I see 4, -10 as the vertex. 4, -10. It's V shape up because that's a positive. And I know that 0 is to the left of 4 because you're going to get a point, 2 points if you can graph this correctly. 0 gets me 8 minus 10. Oh, -2. Well, I wish it wasn't. So I don't have to do any work because of the symmetry. 0, 4, 8 gets me -2. So my answers should be 0 and 8. Those should be my answers. Now I'll take some time with this. We're learning how to write these absolute values as piecewise functions. And you don't have to do both, but if you simply remember putting a plus, minus in front of the multiplier and changing the absolute value symbols to parentheses, you've got -2. The left side of the V shape is going down. So I'm going to solve that problem just to show you that we can get 0. And I think I said 8. And then the +2, x minus 4 minus 10 equals -2 on that side. So adding 10 gets me 8. Dividing by -2 gets me -4. Adding 4, there's my 0. I could use the symmetry like I did before to get the 8 without doing it. But let's do it over here. So there's 8. And I'll show you why there's a sign change here in a second. So dividing by, the sign change occurs here. Now I'm at +4. And when I bring the 4 over, I'm at 8. I hope you could see that. A little dark in here. All right, so I see a square root function increasing. So this is -4, -3. I want a height of 3. So I don't know where a height of 3 is unless I put another number in. So let's put in, how about we put 5 in. Let's put a number 5 in. Let's say 5 is there. 5 plus 4 is 9. Square root of 9 is 3 times 2. Oh, God, I found the answer. Let's put 21 in. 21 plus 4 is 25. 5 times 2, 10. Minus 3 is 7. All right, so I have a height of -3, a height of 7. I want a height of +3. So +3 is a little bit further along. I got a nice drawing here, actually. Pretty nice drawing. Not trying to scale with the x's, but the y's are pretty good. And so now I solve this. So -3 goes the other side, it becomes +6. Dividing by 2 is 3. Getting rid of a square root is squaring. That's 9. Subtracting 4 is 5. So 5 was correct. 5 did get us a height of 3. All right, last problem, thank goodness. Yep, running out of breath even. All right, so what's the easiest way to do this? Well, it's cup shape up. Let me find the vertex, and then I got an answer. Minus b over 2a, minus 12 divided by 4 is -3. If I plug in -3, minus 36, minus 8, minus 15, minus 23 plus 9, minus 23 becomes +23 plus 9, which is 32. Okay, I could have factored it. I know that now, but my answers are x equals 3 plus or minus the square root of 32 over 2. All right, so that square root of 16 is 4. So 3 plus or minus 4 gets me answers of 7 and -1, which means I could have factored this. But first off, well, I got that, right? I got -3. -3 gets me, I shouldn't put 32 in there. Got to do it again, minus 23. Okay, and I want a height of 9. So how do you get from minus 23 to a height of 9? That's why that 32 shows up. Okay, and so what I really had in my mind's eye was I had this in graphing form. And minus 23 here equals 9. So having done so many of these, I know the last thing that's going to happen is that's going to go to the other side. 23 and 9, 32 divided by 2, 16. So that's what allowed me to say that. Now, let's do the factoring as the last bit of practice. So we bring the 9 over and we have minus 14. equals 0. We hit heavily on what's the first rule of factoring Friday? What's the first rule in writing products? Take out what's common. So I hope you would divide by 2. Now we can see the factored form, x plus 7 times x minus 1. I cannot remember what I said before, but I hope I said minus 7 and 1. All right, there we go. Now, how long would it have taken if we didn't write anything out and just wrote the answers? Whole lot less time, but you got to get a lot of practice in to be able to do that. I've obviously had a lot of practice. Okay, you want to play soccer well, get a lot of practice. Why? Because you don't have to hang on to the ball as long, and then people aren't trying to knock you over. All right, there you go. Your tip for the day. Everything comes back to soccer because soccer's played on a rectangle, and all the math is generally coming from rectangular relationships at the high school level. Wow, what a statement that was. All right, ciao, ciao.